Good day, kids. I hope you are having a fantastic morning, afternoon, or evening, depending on when you are watching this. But we are finally on our last lesson for chapter 1. And this lesson is just more kind of basic geometric terms that we will kind of use through the whole school year. So we're talking about two-dimensional figures. And this is what your notes should look like. Okay, once you're ready, let's just get started. So our first word that we have is a polygon. And all a polygon is a closed figure formed by segments. So a few things about a polygon. Let's see here. Obviously, this would just be a side of your polygon or your segments. And then where your two sides meet, form these little, I kind of want to call them corners. Maybe that's not the right thing to say, but their technical term is a vertex. The little corners are your vertex. So multiple vertexes would be vertices. And then just a thing to note is since your sides are made up of segments, they will all be straight. You can't have any curves in it, okay? So this next little part is kind of a good diagram of what qualifies as a polygon and what does not. So if we look over here on the polygon side, we all can see that all of our sides are straight, that's closed, there's no openings in any of my sides. I mean, some shapes are just kind of wonky looking, but this is technically a polygon, even though it's not a shape we typically see. Whereas if we look at the not polygon sides, like this one crisscrosses, that's not allowed. This one's open, therefore it's not a polygon. This one curves, we have to have straight sides, so it's not a polygon. This, we can't have like extended sides. I mean, like what's happening here? No one knows. And then these bottom or last two are curved, so we know that those also do not qualify as polygons. So now based on our polygons, we can classify them even more. We have convex and concave. So a polygon that has no vertices that fall in the interior of the polygon is considered convex. On the opposite side, a polygon that has one or more vertices that do fall in the interior of the polygon is considered concave, and think like it caves in on itself, like it comes inward. So again, we have a nice little diagram here kind of telling us what qualifies as a convex versus non-convex. So do you guys see how all of my vertices are kind of like on the outside? Nothing comes towards the inside of my polygon here. Whereas all these ones, oh, I'm dipping in. All these little indents come on the inside of my polygon. So, and this isn't even a polygon, so that shouldn't even be in there. So you guys see the difference? How these ones cave in on themselves and these ones do not. So convex versus concave. And now we have even more ways to classify a polygon. I mean, it just keeps going. So many new words. But I think you guys know these words, actually. So equilateral polygon. Do you guys see the word lateral? Does anyone know like what lateral means? If you don't, if you're like a football person, like a lateral pass is just like to the side. Like, you know, you throw it to like your side. So this means side. So this literally means equal sides. So a polygon in which all sides are congruent. So all your sides are the exact same length. Equiangular. We have the word angle. Equal angles in a polygon. So a polygon in which all angles are congruent. Equiangles. Equal angles. Now a regular polygon is both. It has equal angles and equal sides. It is a polygon that has both, let's just say equal. We guys add the word equal. Equal angles and equal sides. So it's considered regular. And then I just threw in this little chart in your notes just so you have it in there. I think you guys know that a 3-sided figure is called a triangle, a 4-sided figure is a quadrilateral, 5 pentagon, hexagon, and so on. Just so you guys know. And then actually after we get to like after 12, we don't really have a name for those. So let's say I had like a 22-sided figure, it'd be called a 22 gone. So whatever the number of sides are, you just throw that number and then the word gone. So like a 37-sided figure, 37 gone. Does that make sense? We rarely talk about these ones because who's ever seen a 37-sided figure? I don't think I have. But if I did, I would know how to name it. Okay, flip to the next page or to the back. It says, name the polygon by its number of sides, then classify it either convex, concave, regular, or irregular. So kind of a lot going on here. So let's first look by the number of sides. That's pretty easy. We just have to count. So let's see, 1, 2, 3, 4, 5, 6. A 6-sided figure, if you don't know, look at your little chart on the previous page. But we know that's a hexagon. Then we're classifying by either convex or concave. Well, we notice that it dips in right here, so that would make it concave. It's coming in. And regular versus irregular, so remember, regular means all sides and angles are the same, and irregular would mean that they're not. So if I look, let's check out all of our sides. So do I have one tick mark on all my sides? And I'm sorry that this copy is not very great, but I have one tick mark, a tick mark, tick mark, tick mark, tick mark. So my sides check out. Now we have to look at our angles. Do all of our angles have the little archy marks on them? This one has one archy mark. Ooh, but this one has 2, which means that those 2 are not the same. So we're already done. I would already know that this would be irregular. All right, let's try the next one. So start by the number of sides so we can name it. So if we go around, 1, 2, 3, 4, 5, 6, 7, 8. An 8-sided figure is an octagon. Convex versus concave. Is it caving in anywhere? Not that I can see, so it's convex. And then regular or irregular. So let's check all of our sides. Do all my sides have a tick mark? Let's look. 1, 2, 3, 4, 5, 6, 7, 8. So my sides check out. Let's look at our angles. Archy mark. Oh, guys, I'm thinking we're good to go here. All of our angles have just one little archy mark, which makes it regular because all of our sides and angles are the same. Okay, moving on to the next portion of our notes here. We are just going to be finding perimeter, circumference, or area. Again, it's either going to be new to you or a review, depending on what kind of a math history you have with whatever class you've taken before or what school you went to. So either bear with me if it's review or listen up if it's kind of new material. I think the biggest thing on this whole chart is the area formulas, because I think we all know that perimeter is just adding up all your sides and going around it. So let's try this first guy right here. So it says find the perimeter and area of the figure. So here we have a triangle. Let's start with the easy one. So our easy one is the perimeter. I'm going to put P for perimeter. And it's pretty simple, folks. We just add up all of our sides. So 9.5 plus 9.5 plus 10.2. If we add all of those up, we should get 29.2. But then, of course, since they do give us a unit, we're in inches, inches. So if we were to walk all the way around that triangle, we would walk a total of 29.2 inches. Now we can find the area. So if I look at my chart, area of a triangle is half its base times its height. So half base times height. If you don't know how to find your base and height, it's very simple. Your base and height are always perpendicular. So you look for our little box, and that would tell us that our height is 8, and our base would be 10.2. So if we plug in half our base of 10.2 times our height of 8, we find that our our area is 40.8, right here, inches, but now since it's area squared. How do you feel about that? Have we done that before? Was that uncomfortable? Let me know in class. Okay, and our last one for notes on this video will be this guide to the right, and we'll do the last one in class when I see you next. So it says the area of a circle is 32 pi square units. Find the circumference of the circle. So we're kind of working backwards. Okay, so let's break it down. It says the area of a circle is 32 pi square units. Okay, that's helpful. Let's look here. Here's our area formula. So I'm going to write it down. Area equals pi r squared. And now they told us that this equals 32 pi. So I'm going to plug 32 pi in for my a, since that's how much it equals. And what's nice, you guys, pi is just a number, right? We just represent it with a symbol. So if I'm trying to find what our variable is here, because we got to figure out what our radius is to find out their circumference. Okay, let's go back a second here. So our circumference is 2 pi r. So our goal on this part over here is to figure out what r is so I can plug it into our circumference formula. So right now, our job is to find what r is. So we got to get it by itself. So like what I was saying before is it's nice because look, I have pi on both sides, and pi is just a number hidden in a symbol. So we can actually divide by pi. Our pi's will cancel, so we have 32 equal r squared. And now we all know, how do you undo something squared? Well, you take the square root. The square root of 32 is about 5.7. So we just found our radius to be 5.7. And now it's super easy to find our circumference because I know what my r is, so we just have to plug it in. So our circumference equals 2 pi times 5.7. If you crunch that into your calculator, you should get about 35.81. And circumference is like the distance, it's like the perimeter of a circle, but since it's not a polygon, we call it something different. So it isn't just a linear measure. So what is our units? Oh, just square units. So it'll just be 35.81 units. Okay, kids, thank you for watching. It helps when you guys do your part so we can keep our reviews short in class since you know what's going on. Have a super rest of your day, and I will see you in class.